Hello everyone. I hope you guys can hear me. I'm Kaushik. I work for the Gerrit team in Qualcomm. So we have been working mainly on um, making the upgrade perform better for our large Gerrit site. So I hope you can also see the presentation. So let me make it full screen. So we have a few speakers today. So firstly, we have Martin to take us through the initial slides. So I'll now mute myself and let Martin speak.
Hello, everyone. Hope people can hear me. So it was nice to see the poll there about reasons that people had problems getting upgraded, and I was actually surprised to see that quite a few people still are having problems with the upgrade times. So this discussion might be relevant. Um, Surprisingly, I was not one of the ones who voted for that. So because for us, upgrade time probably is no longer an issue. So I'm happy to report that, and I hope that is going to be the case for others too. Um, I hope that next year when we have this, that when we do that poll, that no one is left that hasn't at least has a system before 216. However, of course, we plan to be upgraded around this year to be on that 216, and so hopefully, if anyone's left, we're the only ones left that are still 216. If we're not the only ones left, hopefully no one will complain about upgrade time as being the main blocker. And if they are, I'd be surprised, and it'd be worth finding out. I would love to know why, and maybe see if we can help people with that, because I'd love to make sure that's no longer the blocker. Okay, give a little background here about us. So we're running probably the oldest version of Gerrit out there. Hopefully, we're still running a 2.7 version. It's our fork, and we also have even forks of our JGit version that we run in there. We have a lot of custom code in there, although by now we have moved the majority of our custom code into plugins. So the fact that those plugins have most of our custom code doesn't make it possible for us to upgrade, because those plugins will run on the latest version of Gerrit. So a little more background, we have 8 primaries running similar to HA. Basically, they're running to serve load and HA. We have 15 global replication and destinations, which probably includes about 50 replicas or more total. So that's all over the world that we have different sites. So 15 sites effectively. Our changes, the size of things here that we have a big site, one of the largest in the world. We have over 3.5 million changes, 16,000 projects. It runs on NFS, and we only have around 4 terabytes of data, which is a decent amount, but not as big as some. And just to give you some perspective, the first time we tried doing a migration, the first time we tested it, it was going to take 5 to 7 days. We never even completed the full thing. We couldn't do it. We did some estimates. It was sometime last January. We'll get to that in the next slide real quick. And that was scary. So yeah, here's the next slide. You can see back in January, when we did our test back in January, we did it on data that was several years old. So it only had 2.5 million changes. So that was really, maybe 2/3 of our data only. So any of these numbers here that for January are not how long it would actually have taken. It would have been longer. And so that's total there is 5.5 days. It really probably would have been around 7 days or so, if that. You could see, the schema migrations alone, just to get to 216, we're taking 5+ hours. You could see that, NoteDB was the largest piece that we had to do, the migration, and that would have taken over 3 days. And then after that, reindexing would have taken another 2 days at least. That's, you know, basically a week of downtime, not something that was realistic for us. There's no way we could ever do that. We struggled to get, you know, an hour of downtime. So about a year ago, we decided that if we're going to do this upgrade, we thought about it and said, what would be realistic? You know, what could we do? What could our users potentially tolerate? And we thought about that, and some people said maybe a day, and even that was a lot. And we realized, well, okay, within that day, not all of that can be the data migration itself, because there's other things. We need to upgrade software across those 50+ nodes around the globe. We need time because things don't go well when you're under pressure. Potentially you need to fix things. You need more time than you planned for often. Maybe your testing was, ultimately you're not testing on the production hardware and data. As much as you make it a copy of that, there could always be something different between what you're testing on and reality. So it still might take a little bit more just because it's production data. For example, the database, maybe the way it's laid out on disk is just slower, and because it's been sitting there for 10 years. So the data could be different than when we make a copy of it. So we needed the migration to go much faster than even a day, the data migration alone. And potentially we may need to revert. So we started with a goal of a very aggressive goal of 4 hours. That's still our goal for the total thing. So that includes the schema migrations, that includes the NoteDB, and that includes reindexing. So as you can see here in the middle column, we've gotten it down pretty close to our goal. We're at a total of 6 hours, just a little over 6 hours. And we may already in the next few days, you know, be a little bit better. We have some ideas and we're close to getting a little better on that. It depends a little bit exactly on hardware configuration. We're still tweaking some of that, for example, where the caches are located. And that can give us better times. So we're going to continue potentially working till next quarter through this and trying to get this down to actually under 4 hours. And you know, we think it's probably still possible. It was pretty optimistic and aggressive to go from a week to even under a day. That was seen as potentially impossible. So we think we can get further. Can we go to the next slide? All right, so here I'm just going to talk a little bit about our approach. I won't get into too many details because I don't want to take away too much from what everybody else needs to talk about after this. But you know, the biggest piece to tackling something like this, I found, was understanding your expectations and what in the problem, understanding the problem. And the problem really is one that consists of many things. It consists of what is your data, what is your hardware, what is your config, what commands are you running, in what order, what process are you following, what things affect all your testing, and also ultimately, you know, the knowledge sharing. Are you doing it well? Are you able to read report from other people on the list about how they're doing and what is recommended for you to how to improve things? And can you understand and translate those to reproducible things that you can actually achieve results that are similar to what you expect from what the other people are reporting? So we found, you know, that the setup, again, big things influencing our things like, are you on SSDs? Are you on NFS? Do you have, you know, various settings set, like trust folder stat? We actually thought we didn't have it set for a while, and yet we did, etc. We made a lot of mistakes, and so really understanding that and being able to detect the mistakes means having clear expectations on, well, how long should something take? How long have other people seen it take? Because sometimes you just assume, the problem's unsurmountable and you realize, oh wait, I'm just making a simple mistake. Or maybe you think you tweaked something and you didn't. So really getting a good process down is a lot of that. Some of the switches didn't exist to be able to enable some of the features that made it faster. They weren't available when you ran like init. They might have been there when you ran Reindex, but not when you ran init. Can we move to the next slide? So in our approach, I want to really say that we had a lot of ideas about how to improve things up front. And I would say maybe throw a lot of your biases away in favor of a scientific approach, because we went down a decent amount of false paths. And I think you'll probably do that too. And the more you can get to my first bullet here called test things, the closer you will be to actual science. And we had to test many, many, many things and test again. We had to test our hardware to see if the hardware was performing the way we expected it. We would move to some machines that we thought were considered better machines, and then we'd find that it was going slower, but we didn't realize it was going slower till later. We assumed we had done something else that made it slower, and then we realized, wait, maybe it's not the right hardware. Maybe I put it on a different file system type that I expected. Maybe, for example, our IT installed XFS for us on some things instead of what the file system we were used to. Just all sorts of things were different. So test, test, test. And then when you get some results, see if everyone else has similar results and similar expectations. For example, we found that we had expectations that just didn't seem to make sense. It was taking too long to write certain things. And some of the ways we developed expectations is again via testing, but doing tests of different things. For example, we might just do copies to the file system to see, are we getting the throughput we expect? Are we getting the latencies we expect? Things like that, doing them outside of Gerrit and via other ways than just the one thing we were trying to test. If we're trying to test migration, well, maybe test using Git itself. How long and how fast can Git create refs for on a file system if you're creating 1 million refs or something like that? Is Gerrit approximating what other tools can do? So don't just test the piece of software you're running, test other pieces of software too. That'll help you set up some of your expectations. And when you have expectations that are good, then it's easy to say, wait, this part should be faster and it's not. Why is this so slow? There's a problem there. So and that's like a great thing. When you find a problem, you're like, well, that's something I can fix potentially. So pursue that. But you have to have good expectations to be able to find that problem and pursue it. So we spent a lot of time on that. And then I can't stress here, going back to the beginning, once you have expectations, and don't forget to only change one variable at a time, because often, you upgrade something at the same time and you think it's not going to have an effect, and it does. So make sure you're doing one change at a time. Lastly, the approach, one of the things we really helped us is we figured out how to make our test iteration cycles much faster. If you're going to test something that takes 7 days, well, that's obviously impossible. You can't iterate fast or really get any better at it. So you have to split that up. We started by splitting that up, for example, into the different phases: schemas, NoteDB migration, and indexing. Work on those separate problems. So already you drastically reduce the problem. But then even within it was too much because our data sets were too big. So we started taking subsets of our data set, trimming the database and only operating on a few repos, etc. And took it so that got it to the point where we could iterate fast. Part of iterating fast also meant getting different file systems, starting to use snapshots, working with IT so they could give us snapshots not just on the local disks, but even on NFS, and that we could actually have some scripts to make those snapshots fast. Because when you're working with 4 terabytes of data, it takes a long time even just to restore something to iterate. It may take longer than you want to iterate. to just restore to the initial conditions. So once we had that, we continuously went back to testing. We tested some long things when we made improvements, but that we would always go back to testing shorter when we would develop those improvements. We would cycle over much smaller data sets till we saw improvements, and then we would test it on a slightly bigger data set, because again, we don't want to test that on the full data set if it takes too long. Maybe you have a data set that's a hundredth of your data and you test it and it finally goes fast on that. Then you test it on a data set that's maybe 1/10 your data set. And there you're still able to iterate. You might find some new problems now and you can iterate at that level before you iterate on the thing that takes you several days. So with that, and a great team that was really great at finding lots and lots of problems and fixing them, we made progress, being able to iterate super fast. I just couldn't believe, over time, how much faster we got at finding problems and fixing them. And I'm going to let the rest of the guys talk about how they did a lot of that. Oh wait, I guess they wanted me to talk about this one little piece too, still. So one of the things that we found is there was a problem in JGit at one of the, simply looking up loose refs. Everybody knows that loose refs were slow, but we found that it didn't meet our expectations. It was slow, but it was actually way, 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 way slower than what we thought it should be. And we dug in pretty deep and we found some sort of a combination of two problems. And we found that this is name conflicting piece was super inefficient. It effectively looked up all the refs just to see if a name collided when you were creating a new ref. And so not only was there an inefficiency there, then there was another caching method in the batch ref update that was put in place years and years ago to work around the inefficiency in the name conflicting. And that inefficiency brought in its own problems. It did great in some use cases when you were adding a ton of refs, creating a bunch, like, you could create 100,000 refs really quickly, but that only worked if the repository was blank to start with. For example, when you were cloning. But if you already had 100,000 refs and you wanted to add another 100,000 refs, and then you wanted to do that again, so now you have 200,000, you wanted to add 100,000, etc. This extra caching layer actually slowed things down worse then. So we had to fix both problems there. That single improvement improved many things. It improved the schema migrations, it improved the NoteDB migrations, and hopefully it'll improve things in the current code base too for people. So that's the biggest JGit improvement we were able to do. It was actually 2 improvements, but so now I'll pass off to Adithya. Thanks.
Yeah, thanks, Martin. So let me take you guys through the schema improvements that we did and the analysis that we did to develop those improvements. So we started off by measuring the runtime for each schema and kind of targeted the schemas which were performing slow. And there are a lot of schemas when you consider from 2.7 to 2.16 that were making changes to all users and adding star changes and all kinds of operations and making the repository state bad, like leaving out the loose refs and things like that. So we tried to see the Git stats after each schema, and also try to target the schemas that were making the state of the repository bad. So those are our targets basically. And the next thing, as Martin said, the improvement made on JGit, it's on 2.16. So using 2.16 var for most of the schema migrations would be helpful because they're doing a lot of Git operations. So we tried to do a 2.7 upgrade to 2.16 directly from 2.7, but it was not possible. We had to break out at 2.9 and 2.11 due to some deletion of schema classes and some architecture reasons. So basically, most of the schemas from which include Git operations are from 211 to 216. We basically used a single 216 var, which had all these JGit improvements. So that faster improved things a bit. And the next thing was while using the batch mode, there were some flags that were defaulted to the options that we don't want. So we also developed some switches to override those defaults in batch mode. Yeah. So Kaushik will take you through the next improvements in schemas.
All right, so to continue what Aditya was talking about, so mainly we started targeting all the slow performing schemas, and like I have listed down a couple of improvement categories that we mainly did. So firstly, there was a lot of serial operations that were being done on repositories, so we tried to parallelize that and get things to run faster on those schemas. So I have some timings on the next slide, which kind of show how much we improved by parallelizing things. So we improved around 4 schemas, which acted on repositories and then database operations. And another thing that Aditya was talking about in the previous slide was that we started looking at all users.git specifically and tried to get stats of it after each schema. And we did that because we noticed a lot of schemas were doing GC, and obviously we do GC because the repository is in a bad state. So we wanted to analyze more and figure out why actually the repositories are getting in that state and why the GC is needed. So we found that a lot of schemas are creating loose objects, and we wanted to avoid doing that. So we started updating those slow performing schemas to instead use a pack inserter to insert a single pack and not create like thousands of loose objects. So then not only did that make the schemas faster, but it also helped us avoid doing the GC and all those subsequent schemas. So both of these improvements made schema migration much closer to our goal. So apart from those improvements, there are some other MISC improvements that I'll probably skip in interest of time, but these also helped us get make the schema migration faster. So I can probably talk about the last bullet here under MISC. So during the schema migration, we create new columns and then have default values. So this was pretty slow on large tables for us, but we realized this did not need to happen as part of the migration. This can be done beforehand. So that's what we plan to do. And we also kind of put that suggestion in the release notes for other folks who are wanting to uh, uh, upgrade in a similar path that we have been doing. So all the schema improvements that we have done, we have hashtagged them as schema optimization. So you can take a look at that hashtag to see all the changes. So in the next slide, I've just kind of listed down the changes that we did that are part of that hashtag. And on the right side, you see a table here with initial times with 216.27 and then 216.28 with our improvements, which include all the improvements that we talked about in the previous slides and the JGit improvement as well. So you can see that things got really fast because of those improvements. So all of these numbers are using our full data set of 3.5 million changes. Okay, so moving on, I'll also talk a little bit about NoteDB migration. So before I talk about that, firstly, kudos to the SAP team for making some awesome improvements to the NoteDB migration code. So we were able to take that as a base and pursue more improvements to get closer to our goal. So again, we started profiling the code to figure out, hey, what are the actual bottlenecks and why things are really slow for us. We played around with a lot of things. A lot of experiments were done. We started with trying to pack refs regularly when the migration was happening. And then we again tried different things, like we tried doing the migration in parallel because we have several primaries. We figured we could run the migration in parallel, and each instance of the migration can migrate a subset of projects, and then all of them together will finish the migration faster. And we played around with other JGit configurations. We played around with the batch ref update, and in doing all of that, we discovered actually that writing refs has been really slow for us. And then we started looking at the JGit code, and we reached the improvements that Martin talked about earlier. So I can probably skip the JGit improvement section here. Apart from that, another thing that was really slow for us was querying from DB. And again, we found out that if we warm the DB beforehand, before we start the migration, things get really fast for us. So that's something that we also added as a change in 2.16. So if you're using a Postgres database, you can always warm it before starting the migration. It will probably help for other database types as well, but that's something that we were not able to test. So if you have other DB types, you can test that out as well. The other thing was the GC, which was enabled by default in NoteDB migration on all the repositories, was performing really slowly for us. So we decided to make that optional for now, and then continue with the migration, and we can figure out how to repack the repositories later. Again, like schema migrations, all the changes that were done for NoteDB are hashtagged, and there are a couple of JGit changes that we already talked about. So in this slide, I'm just listing out the changes that were done. Unlike schema migrations, the number of changes here are less because the migration code was already pretty good thanks to the improvements that SAP did. But you can see here that these were the changes that we kind of did to get NoteDB migration close to our goal. All right, so with that, I'll hand over back to Adithya, who will take us through the Reindex improvements that we did recently.
So to start off with Reindex, NoteDB was actually leaving repos again in bad state. There was a single loose ref per change, which was causing all the JGit operations slow. So we identified that, and the next thing is we tried to play with the cache limits, and also thanks to WANDisco, we kind of enabled verbose logging with Lucene with help of them, and were able to make some improvements to Lucene too. Coming to disk caching, there was this particular cache called change kind, which was introduced in 2.10, and our production copy, which is on 2.7, definitely didn't have that. So as part of reindexing changes, to populate this change kind was taking around 70 to 80% of the reindex time. So we tried to pre-populate that cache, and having that pre-populated cache reduced drastic amount of time from the reindex. So we could see at least 70% of improvement. So the next thing is slice creation. So we actually, the current code creates slices based on each project. It estimates the size based on how many change refs are there on each project. So it was doing kind of duplicate work. It was estimating the size and then creating slices, and then each slice go and scan for the change refs again, and they kind of filter out the refs for their slice. So this was a duplicate work, and also having repositories in bad state was making them as costly operations. So we tried to avoid that duplicate work by only scanning the change refs once per project. The next thing was parallelizing those slice creation for our database, where we have around 16,000 projects. When it was serial, it was taking around 3.5 hours to create just the slices. When we parallelized it, it was reduced down to 30 minutes. So next slide, question. So coming down to Lucene optimizations, actually, so the code right now does a flush on every reindex. So the flushes make the updates available to the searcher threads, which is not required on the offline reindexing. And also this flushing is very costly operation, as explained in the Lucene docs. So we try to disable that flush and make that flushes only happen based on the buffer size configuration. So that also improved things a lot. And the next thing is avoiding deletes while doing Lucene index updates. So we start off the reindex operation by deleting the whole index, and then we place everything to the index again. So they were doing an update operation rather than insert operation. So doing that update operation was triggering premature flushes, and we are not utilizing the full RAM buffer size. So we try to improvise things over there. And coming down to this missed things, we did a lot of parallelization, but the thread count, the threads flags on Reindex command was not actually using the threads that is provided by the user. Instead, it's looking at some other config or the default number of available processors. So which most of you might have not noticed, and you try to increase your thread count and your runtime still doesn't decrease. So we fixed that. And also when we try to do an init, init will automatically start a reindex if reindex was never done. So that was doing on a single thread. We added a new flag called index threads uh, to parallelize it. So that all the slice optimizations could be used. On the next slide, you could see all the improvements that we have made, and out to Nasser to explain you our future plans.
All right, thanks everybody. Yeah, so yeah, I'm gonna go through these pretty quick because we're just about out of time, but the slides will be up, everybody can look at them later. So as we talked about, we did some things where we're seeing problems with repository optimization and objects being left around. And so, kind of a theme across here is that we're really trying to look and see what can we do to try to keep repositories in a well-maintained state without adding a lot of inline cost as well. So looking at doing things like packing graphs in the background, doing more to really look at caching and what we need to do to continue to optimize the caching. And then, we want to be able to do more quickly, especially with Reindex. So like Adithya was talking about, we spend a lot of time still upfront scheduling, determining slices when we could already be doing potentially work on those slices. So I think, we're gonna do more there as much as we can. Next one. All right. So overall, next steps. We have the migration. We want to actually be able to get all the data migrated, of course. And so there's a few things left there, including, I think really importantly to me, is we want to be able to get a bunch of recommendations out for the community, right? These, we're doing this for us, certainly, but we want to make sure that everyone can benefit from it. So, like Martin started us all off with, we're hoping that this time next year, nobody has concerns with how fast you can migrate data. We want everything that we're doing here is going to be upstreamed and documented and published in a way that everyone else can consume it and use it. So there's no special sauce, no extra steps. This is just going to be well documented by the book upgrade. And then kind of pre-upgrade, pre-go live. We still have all the regular stuff of just making sure we can use the upgraded version. So we still have some teams on fork APIs. We still want to make sure we get all of our internal plugins converted over and working on the latest versions. And there's a couple features that we still want to be able to get upstreamed, and then lots of QA. So lots and lots of QA. So yeah, I'll drop it off there. I see there is one question so far. So it's you mentioned about GC improvements after schema upgrade. Do you use Git GC or JGit GC during upgrade and after? So we exclusively use Git GC. JGit GC actually fails to complete on a few of our projects. Last we checked, because they are very, very large. And so, yeah, we're exclusively using Git GC. So that's one of the things that we're going to have to figure out. And so the way we have that running in production is it runs across all the primaries in conjunction using our lockers and collections frameworks, which are partially open sourced. Are there any other questions, Luca?
No, but there is one question from me. That is, first of all, thank you very much for the improvements. I believe they're beneficial not just for the migration, but for the overall Gerrit project, because all the improvements you guys have made have been merged up to 3.5. So all the improvement at JGit level, they will benefit 3.5 and all the recent releases as well. And the second question, the second that is really a question is, when are you guys planning to complete the migration?
Yeah. So we are. I've got 2 tentative dates for actual go live, and they may shock you. They are December 3rd and 10th of 2022. So we are, like Martin said, about a year away. But I am currently in the process of wrangling all of the teams onto that schedule. So it's going to be a lot of work to get everybody to actually align to that.